About like this? Okay. I would like to get started. This is not a parish mission. This is a retreat. So I am a retreat master. Now that is a canonical office, the retreat master. Okay, there was a slight shift in the wording, and so this is a retreat, and which means as part of the retreat, these nights I'm with you, I can change and modulate anything on the retreat schedule. So we've got a lot to talk about tonight. Make sure you can see the screens where you are. One thing to change on this retreat is any of your Lenten culinary observances are abrogated while you're in this room, okay? So just to let you know, okay? They're gone. So if you bring something with you, BYOB type stuff, okay? I don't recommend that, but I do recommend BYOF. Bring your own food, okay? Because it's abrogated while you're in this retreat. That's why we have popcorn. Enjoy the popcorn, especially tonight. This is a fun one. Tomorrow will be nifty. We'll bring up some things maybe you haven't thought about. Over there, against that wall, are a bunch of rosaries. They're blessed. They're free. They need a home. So take rosaries. I have 3 times that many back at in my room at St. Pat's, and it's getting cluttered. So if you know someone that doesn't have one, if you don't have any, if you take one, remember to pray for this retreat class. You've crossed each other's paths. There's a reason you've crossed each other's paths. It's to pray one to another until we get to the far kingdom. Okay? There's a reason we're all here. Okay? No one else is here, just us. So keep that in prayer. Then there are my resources over on that table. You can't have those books. I had a retreat, and one guy saw books like that, and I didn't see 4 of those books after the retreat was over. I hope he used them well, you know. I hope he used them well. But those are my resources. You can get your phone and take a picture of it. I recommend every one of them, especially Lee Strobel is excellent. There's a couple. Stealing from God by Turek is fantastic. And then some of the ones I've marked at the bottom of the page, excellent. Some of the photographs of the front cover. You'll enjoy them. With that, let me start we're going to go for 40 minutes, and then we're going to have a 7th inning stretch. I had a teacher who, and we're gone. I had a teacher who would go, and it was a 55-minute class, and he'd go an hour and 15 minutes, an hour and 20 minutes. And his best friend, who was the next class we were supposed to go to, we would show up late, and he would dock us points, okay? And together, they were in World War II. They were in the military, and what they said was, we're not allowed to yell at them to stress them out, because that's what DIs do. They yell at people to stress you out, right? Any military, you know that. He says, we're not allowed to do that nowadays, but we can make them miserable by docking them points. And so they did that for years, okay? I always hated it. When that thing goes off, we take a 7th inning stretch and then get back to it. I do have a lot of information, so let's begin with a quick prayer. In the name of the Father, and of the Son, and of the Holy Spirit. Lord our God, we ask you to be with us tonight. We want to know you in a deeper way. We want to know your grace and mercy. We want to know that you're around us and be able to see your hand working around us. Give us an insight of everything we've got here and help us appreciate all that you do for us. We ask this in the name of Jesus. Amen. Father, Son, and Holy Spirit. Without that, let's begin. We're going to look at faith and science. Are they enemies or are they friendly? Are Catholics afraid of science or deny its ability to discover, to be able to plot out things? And so, when you see this, that thing, that red hot chili pepper, that means it's absolutely essential for life on earth. If you don't have whatever shows up with the red hot chili pepper, then you cannot have life, okay? So, for example, when we talk about oxygen, it's going to be a chili pepper. You got to have it. And by deduction, any other planet in which you're going to get life as nearly as neat as we are is going to have the same thing, right? It's not like you can make breathing beings out of lead for air, or Venus, that atmosphere goes up 800 degrees in one day. It burns everything. So you're going to have a lot of things like we have on our planet. Here's a word about pickles. I use this to high schoolers. There are 5 things necessary to get that kosher pickle. That's right there. Okay? 5 things have to come together. Okay? You've got to have the pickle. It has to be a certain size, that pickle. It has to be a flavor genetically that the pickle people want. Those are Van Holten's. The liquid inside can't add flavor or detract from the pickle. Chemically, it has to be very, very exacting, that liquid, or it'll destroy the pickle. The plastic cannot interact with the liquid or the pickle, or you're going to have a plastic-taking pickle. The ink with letters not only cannot react with the plastic, and then with the liquid inside, but they have to be intelligible and attractive, and to an American audience, it has to be in American English, or we're just not going to be able to know what's going on there. And lastly, the opening, that nifty opening, and the way it stands. Look at this. Isn't that neat? It stands. The pickles, it has legs. That's highly engineered. I mean, a bunch of engineers got behind this, okay? That's pretty amazing. And it all comes together at the same moment when they make that pickle. All that stuff. All at just the right manner, the place and time. It shouts, this is engineered. A lot of people went into making up something like this. In the same way that a lot of people and a lot of things had to come together to make a book. The ink on it, the quality of the pages, it's so fine. It used to be real rough, like burlap, like a grocery bag paper. The leather on the outside, that means some cow died for this book, you know. The cut is so smooth. A watch has parts from all around the world, and they're sent to foundries, and that iron ore or whatever it was sent to a craftsman. It all comes together right here with a watch. Kind of like when we'll look at this again, this is a rat trap, okay? Different parts from different parts of the world coming together. Nature, tornadoes never made something like this. Look at the edges on that. They've been precision tooled. The metal here is not found out in nature. It comes from human hands. And so all that coming together to make this specific thing shouts engineering. More to our topic. Think of math. Everyone here has studied math to some level. I had to have 2 years of calculus. My degree's in microbiology. If any of you teach calculus, what is that? It actually worries me about Alzheimer's, because all those brain cells aren't functioning right now. All the ones that learn calc, they're just kind of like gone. I don't remember any of that stuff. I haven't touched it since the 1980s, but I still can't, generate any of it. The math that we began to study in grade school is the same math. It's a language that's used to understand things 1,000 light years away from here. Isn't that weird? The things we're teaching our 9th graders are applicable 1,000 light years on the other side of the universe. The physics that we began to study in high school is the same physics that's working throughout the universe. And we know them. We should think that's amazing. We should just think that's amazing. The periodic table, I love this thing. I have a mask that's a periodic table, okay? The periodic table, did we make it up or did we discover it? We discovered it. The relationships that are going on here, those groupings that are here, what they call valence and groupings, and this has some things in common with this side, all of that we discovered. We didn't make this up. This is the way nature is. Okay, this isn't a human construction. It was discovered. The guy who did von Leeuwenhoek in this area, he left blank cards. He knew what this one was going to be and this one, and he left a blank card saying, this one has to have the atomic weight of this, and we know it. And he was able to predict without doing the work because it's so predictable. Okay, it's so ordered, it's so measurable, and there's a beauty to it. And then these are the cosmological constants. These are the stuff that keep the universe going. And if they change, we're in big trouble. Look at how fine some of these measurements are. 1 over 9.1 with 31 zeros after it. And if you change any of it, you're not going to have life like we know it. Okay, it'll destroy the universe. Speed of light, if it's not exactly what it is now, you're not going to get our chemistry. You're not going to get a lot of things. And so this is amazing. It is so Avogadro's constant. We had a sports team in high school, and every one of them had that number on the back of their jersey. They were nerds. They were classic, delightful nerds, okay? But look at the size of that number, and all of that is what our galaxy is based on. There's right now about 200 parameters for life to happen. Here's one that's a little more close to home. The chances of these happening randomly, or the chances of it happening, because I went to the accounting department, because the head of accounting is a member of St. Pat's, and I said, what's the chances of that happening? And they dove on it. They ordered in coffee and donuts. They stayed overnight to crank it out, all these numbers, eggs, heads. And it's 1 times 10 to the 18th power. It's one chance in all of that, because it's also on the other side of the building every Christmas. That's how much. To have all these numbers is a lot bigger number than that. It's about 1 times 10 to the 56th, and that to the 152nd. It's a giant number. It's more numbers than there are atoms in the universe. And so, according to a number of scientists. But scientists generally do not verify. They don't verify to see if the principles of reason or logic, or the laws of causality, cause and effect, or mathematics, or the fundamental constant that we just saw a moment, or the chemistry or the laws of physics are the same out there as they're here. They don't verify that. They presume it. Force equals mass times acceleration. They don't verify it when they look out at the next planet passing. They learn if there's planets because it passes in front of the sun and the optics change, right? It's all about optics to figure out new planets. That's all they got. It's good, but they're using just what we learned in physics, optics. They presume it and they rely on it for their work. Correctly, they're able to predict things, but they don't verify if the periodic table is the same out there. They presume it. How can they do that? Do you know what's happening 5 doors down from your house? Most of us would say no, okay? We know what's going on 3 galaxies over. Isn't that bizarre? How come? Why do we take that for granted? Why is that? Why not expect random chaos or nonsense out there? Why do we expect that what we see here on Earth is going to be applicable out there? Like a math teacher teaching math out of accounting in his accounting class. And actually, isn't it amazing? It actually applies to when you go to work for an accountant. But that should amaze us that what we learn in the classroom of this planet is applicable anywhere but on this planet. But it is. Isn't it amazing that the subjects we study in this planet are the very same that are applicable across the universe? Art class makes art museum intelligible, or math class. And all that came from a giant explosion called the Big Bang, a wonderful creative life, intelligence causing massive explosion. Have you ever seen the incredible creativity of a tornado? Or how about the tsunami that happened a few years ago? Or just a dynamite explosion? Does anyone go to those sites to say, let's see what beauty it made? No, we don't. But that thing sure did. Yeah, let's get our topic going. We're going to look at from our galaxy down to our planet. And that's what we're going to look at, the latest findings of science. So let's do that. This is our galaxy. This is the Milky Way galaxy. It has arms, and they're named, the Norma, Near, it's got these different stuff. Swirling, I think it's going that way, clockwise. And our sun is found roughly between 2 of them. Our sun's right there, near the Orion Spur. Our galaxy, Milky Way galaxy, is circular, roughly, but it's a flat galaxy. In the center, you've got supposedly a black hole, and that just tears things apart because the forces are so strange. And then you have star formation going on in the center of some of the arms, and elements being formed, and they're coming together outside. When you get down to our sun, we got really lucky, okay? We got really lucky in 2 ways. Let me go back to that. Which means, since there's things going on, there's explosions, you can't live here. Here in the center of the galaxy, the black hole will tear everything apart. But also, there's supernovas going off. There's huge explosions of energy, and they will tear up anything like DNA. Any fine structures can't live in those environments. They're too close. There's too many suns. There's too much going on. There's too much radiation. It's not like life. Star Trek imagination can say, you can have life that eats gamma rays, but nothing on our periodic table permits anything to eat gamma rays. They destroy electron bonds. They destroy it. They do damage to anything living. And so you can't live there, but on the outside of it, there's not enough material made to make a big planet. You may have an asteroid or something, but you don't have a big planet. There is actually something called the Goldilocks zone, and it's a place where it's just right. Not real too close, not too far, it's just right. We happen to be in the Goldilocks zone of our galaxy. The sun we're near, here's our sun right about here. It's not quite in the center of age for suns, but it's a mid-sized sun, okay? It's not one of these giants that you see out in the world. It's not one of the blues or the reds or one of these small things, okay? The smaller they get, the more gravity they get. Planets that get near something with huge gravity, planets, will stop rotating, and one side will get burned, and the other side might freeze. That's what happens with Mars. Here's another thing of how suns go. The star formation goes through a sequence, and ours is in the main sequence right now. It's a main sequence star. Eventually, it'll become a black hole, a neutron star, white dwarf, a dead star. And I said, here's the Goldilocks zone. If you're not in the Goldilocks zone, there's no life, because there's forces out there that don't permit planets on the outside, and there's incredible nuclear mess on the inside. There are suns out there. I'm going to go back and fix that when I use that. That slide's out of place. Here's Saturn. If we were like Betelgeuse, a giant star that we've measured, the size of it would be that big compared to ours. Okay? Luckily, our sun's not that big. Here's our sun, and around our sun, there is the same. There is a Goldilocks zone. If you're too close, the heat of the sun will burn off your water. We need liquid water to have life. It is the stuff of life. It's what everyone, when you're looking for life anywhere else, you got to find liquid water. If we were too far, you're too far from the effects of the sun. It freezes out, and that's Mars. If it had liquid water, it's all frozen now. It's not doing any good on the surface. If the sun was any bigger, its gravitational pull could lock in the rotation, and then you get one side getting fried and the other side freezing. If the sun was smaller, we'd have to get closer to it, and you'd have the same thing. Its gravity would eventually stop our rotation and lock us in. We got very lucky with the size of our sun, its age, and where we are. Mars is outside the Goldilocks zone, so you may find some little crud underneath one of those caps, but you're not going to find the plethora of different forms of life as you find on our planet. As it says, the habitable zone. Venus is outside it, Mars is outside it, we are right in it. If you go 15 degrees more percent towards the sun, you're going to be outside it. If you just move 5% more from our distance from the sun, away from the sun, we're going to be outside it. So we got really lucky in being in the habitable zone with our sun. Another thing we got lucky at is the planets. I've got them here. Relative sizes are right here. We've got stinky little Earth. That third one over, that one's Earth. Here's our sun. Third one over is Earth. And that big red one to the right, that is Jupiter. Okay? And Jupiter and Saturn, because they have mass, they're gas giants. Weird physics, weird chemistry there, but they're gas giants. And they have an electric pole. They have an electric pole. And they've actually got pictures. They were looking at it, and they saw a meteor impact. The gravity of this, it is thought, cleans out a lot of the flying garbage in the inner planets and sucks them into these two things. They look after, in a sense, by their gravitational pull, the inner planets compared to close to the sun. And so, this is what someone said, don't worry, buddy, I'll take care of you. And that's us, okay? That if we didn't have Jupiter and Saturn there to use their gravity to pull stuff away from the inner planets, what happened to the dinosaurs probably would have happened multiple times. This is from learnastronomyheadquarters.com. All my sources are secular sources. There's no religious sources in this, okay? Because most people would think, well, that's argument from authority. No, this is the science of it. Why is our Milky Way system maybe unique, our solar system? This is it. We expect elsewhere to be equal to what we've got here, you know, a sun, rocky planets, gas giants, all going around in nice circles that don't overlap. We expect that to be found everywhere. And that's not what we're finding. Rather, we're finding the organization of rocky planets close to the sun, and then you get gas giants. We're not finding that. We're finding places where gas giants are right next to the sun. Okay, and it's its gravity that keeps it from just fizzling away. So it's not like the symmetry in the sense of our solar system. The circular orbits with spacing between them, no. We've got it's not perfect circles, but we've got circular orbits that don't overlap. That's not at all what we're finding. So what happens when two planets overlap? Eventually, they're going to hit. Eventually, they're going to smash into one another. That has serious problems as far as your building project, right? Okay, another planet comes and blasts into you. We think there's going to be one star in the middle with planets circling it, and that's not. One estimation is that 85% of the stars in the Milky Way galaxy are binary stars. Twice as much radioactive garbage, the explosion of those nuclear explosions called suns, is coming out at every planet with twice as much of the gravity and all that, okay? So it's not this thing that we see with our solar system. The orbits stay at a distance, especially for gas giants. They stay way out there. No, they weave. They spell their name in the space. You know, there are some weird stuff out there going like that. It's not at all what we see with our solar system. Rocky Earth-like planets are common? No, we're finding they're not. To have all that stuff coalesce, for us, it was fissile material, uraniums, plutoniums, all that, that's fissile material, inside an iron core. And then around it, all the rocky mass came. And which means our iron core is about as hot as the surface of the sun. That's not what we're finding out there. They're finding a lot of gas giants, or they're finding things that are so gigantic that the force of gravity would never let anyone grow tall. Remember, you got to have the right gravity for things to grow tall. You have a strong enough gravity, you're going to be like something that just crawls along the earth, along the surface. And wild contrary orbit ellipses. This is all over the place, which means with enough time, they're going to run into one another. That's the way the rest of the universe is. It's not this highly circular elliptical stuff. This is from Scientific American. In our solar system, the gas giant planets, Jupiter, Saturn, Uranus, and Neptune, spin more rapidly on their axis than the inner planets do and possess most of the system's angular momentum. That's a whole other thing in physics. The sun itself rotates slowly, only once a month. The planets all revolve around the sun in the same direction, in virtually the same plane. We're all in the same plane with our sun. We're not all over the place. We got lucky there for a number of reasons. In addition, they all rotate in the same general direction with the exception of Venus and Uranus. These differences are believed to stem from collisions that occurred late in the planet's formation, okay? Meaning with this, because there's this unity of sorts, one directionness, we got really lucky, okay, in being in a solar system like this. The same plane, and there's roughly elliptical or non-touching orbits. This thing is a comet. So, again, incredible luck. If you didn't have it, you're probably not going to have advanced life, because you need a stable planet to develop through centuries and millions of years organisms like us. Let's look at the Earth's atmosphere, the moon, the surface, and the interior. Our star is our sun. It gives off a lot of radiation. Infrared, ultraviolet, bunch of different types, X-rays from flares, and lots of visible light. These are all the types in the radiation spectrum. Radio waves, TV waves, microwaves, all this. When you hear of, oh my golly, we got radio waves from this other galaxy, stars give off this spectrum, long waves, which we call radio waves. They give it off. It doesn't mean there's a transistor radio out in Alpha Centauri. No, No, okay? It means stars give off radio waves. So this is it. Now, this is the stuff of hydrogen bombs, gamma rays, gamma radiation, okay? One particle can go through and it causes a mess, not like a bullet. It just does things on the atomic level. Well, our sun, think of this, okay? Our sun doesn't give off the most of this. It doesn't give off this stuff. Our sun gives off a real small little bit right there, which happens to be the visible light spectrum. It's white light, and when you break it down, it's the visible light spectrum. Because if you didn't have this, you wouldn't have photosynthesis. Plants love that, and our sun happens to give off a lot of it. We got incredibly, where's the jalapeno? We got incredibly lucky by having a sun like that. Our atmosphere filters out a lot of the stuff that comes from our sun. Gamma rays, they're formed in the center of the sun, they think, but the sun is too large for them to get out to us. We don't get gamma rays from our sun. Aren't we lucky? We get a lot of white light. It filters it out. The oxygen and nitrogen, don't you love that? It's inert nitrogen. We need it for proteins, but we don't get it from breathing it in. It's inert. The size of our lungs, the surface area, is about the surface of a tennis court, folded and made smaller if you took the surface area of our lungs of an adult and spread them out. It filters out most of the garbage. Here's a diagram that shows it. Here's the stuff coming from outside. You're going to get X-rays, extreme ultraviolet rays, far ultraviolet rays, things that they study in physics and optics, visible light. Most of these are stopped because of ozone, oxygen, and nitrogen in the atmosphere. Some other of our gases will stop things in the atmosphere. Solar protons are things that are zipping out from different stars. But visible light comes to us in abundance, but also, you know why you have to use sunscreen on a sunny day? Because some of this gets through. Some infrared gets through. Infrared A and infrared B, I think it's called. But those two touch the planet. The others are stopped because of our atmosphere. If you didn't have this, you're going to get all this stuff slowly, chemically cooking the surface. Now to talk about our moon, which also affects the planet's surface. Moon, there's some theories of how it was made. It's thought that there's something that impacted the Earth. Our axis was perfectly stable, and this thing came into it and blasted it. It's the pool billiard shot of the centuries. It's absolutely a perfect billiard shot. Where it came, the cue ball mashed the 8 ball, and the mash took off and started circling it and became a whole body. Just try that on your billiard table. Try to hit one ball. The angle had to be perfect. It just couldn't be a slam in the center of it. The speed had to be right. But they think that's what happened. It knocked our tilt off, and currently our moon stabilizes our tilt at about 23 degrees off center. Boom, artist rendition. Now, one person says, when a planet cools, the planet was hot and started to cool, it cools universally. One scientist said this, and it cools over it because you're in the middle of freezing death cold, it's in the middle of a frozen space. And so you have universal cooling. Well, this planet, Theia, I think they actually gave it a name, this thing that hit us may have gouged out a part of the crust, and that may have let us have plate tectonics, okay? The crust parts can move because this thing gouged out a bunch of the surface of our planet. Just theory, they can't do it. There it is, Theia. Did that, knocked it off center, did this. It actually slows down our rotation. There was a time when our rotation was not 24 hours, it may have been 8 hours. Imagine what the winds were like, 500 miles winds constantly. You wouldn't get delicate structures like flowers. You wouldn't get things that can't live in wind like bees, okay? It would cut into life on our planet. The moon affects our rotation speed. It slows us down. It affects our tilt. 23 degrees, and it locks us in. By having that there, here's the Earth. The moon locks us in at that angle, and as it goes around us, it keeps us at 23 degrees. It also stops our wobble. We have a very small wobble because of this. Now, Mars, they believe, has about a 30-degree wobble, which means the aspect facing the sun is going to change radically in a planet doing that, like a roller coaster or something at a fair, okay, that's getting thrown around, and you're not going to get steady, long, predictable soakings of sunlight, and it's going to affect the life on a planet. The moon stabilizes our wobble. The moon affects our water. Any people do sailing here? I was up at Quebec, and I was right on the St. Lawrence River. I think it was in Quebec, maybe Montreal. And you know what it's called when the water all gathers together by the force of the moon? Tides. And so what it does, in Quebec, it's a 30-foot difference. I was there in the morning having orange juice with some stuff in it and a cigar, like at 6 in the morning, and it was flat. And then 12 hours later, that place was underwater by like 20 feet. It was incredible. I've never seen it. The moon does that. The moon attracts water to itself. It also mixes different temperatures together. The temperatures from the northern part of the world, our sphere, and the temperatures from those waters heated up at the equator, and it mixes those temperatures together. Now, as far as the moon, we were pretty lucky because the garbage that came coalesced and became our moon, okay, when we got splatted. Saturn, less so. It still has, and there's a diagram of it right here. There's a plastic model. It still has those lovely rings, but it doesn't have a moon affecting it, okay? It's a gas giant, so who knows, it may not have needed it. But we don't expect life to be there on Saturn. That's our moon. Look at how close it is to Mercury. That's a big moon. It's about 27% the size of our Earth, okay? 1/6, people say. It's pretty big. It's pretty big. The moon, because of its tilt, goes against the sun in 4 different ways. It instead of just being one going around the sun, and the equator is always getting hit by the sun at the same amount, there's 4 different ways, and it gives us 4 seasons that are slow to come in. They're not abrupt, they're predictable. And so because of this, you get 4 different seasons. 4 different times you have a different closeness to the earth around there it's close, here it's far. That would be summer there, that would be winter. That winter here for that same place. So that's because of our tilt and our moon that's keeping that tilt. Moon also attracts water, and so it mixes temperatures, it mixes the highly mineralized water off the land, and mixes it with the ocean waters so the oceans don't die. The oceans are a fundamental source of life. It's the basis of all food pyramids. And if you didn't have the moon mixing it, latest theories are saying you're not going to have life. You're going to have no oxygenation, no mineralization, no mixing of temperatures. All that goes because we have that moon. There you go. The oceans distribute heat from place to place and mixing and distributing nutrients. Those tides because of our moon. And so, you got a lot of necessary things. The moon helps us in many ways. Its formation may have caused tilt and caused plate tectonics by removing part of the crust as we were slowly starting to cool down. Our tilt is stabilized. That's absolutely essential for life. So we have gentle seasons. The tides, the currents are formed, thereby mixing temperatures. And it's mixing the nutrients from freshened seawaters. It mixes it so there's life there in those things. And the oxygenation in mixing oceans is due to waves and that wave activity. The rotation is slowed down, so we get longer periods with sunlight, but not too long. The latest science says no moon means you're not going to have a stabilized tilt. You're going to have erratic seasons, no slower rotation, which means poor sunlight. It's going to whip too quickly to get it happening, get it warmed. And no mixing, oxidation, and temperatures, which means dead oceans, which means no life. You have no moon, you got no life. And so any other planet we see had better have something like this, or there's not going to be life on it. They're going to have to do with all this garbage that the moon stops with us. We got really lucky because we have a moon. That's like we won the lottery on that one. You're more than halfway, so hold on, okay? Feel free, if you need to get popcorn, go ahead. Anything else, go right ahead. So let's look at, there's our planet. Let's look at water. Water is awesome. Water is a unique substance in the universe. It does things nothing else does. It has cohesion and adhesion. Remember, this is from our 9th grade earth science. Remember that? And it's so what happens is because you have that, this water molecules hanging on to one another, that when it's respired off the top of a plant, like a sequoia, you're still going to get water being dragged up from the ones that are below it because it sticks together, okay? Temperature moderation. To break water molecule bonds needs a lot of energy. So when they get hit by the sun, for example, in the ocean or in ponds, those water molecule bonds begin to expand, but they don't break. Instead, it goes from liquid into a vapor. It evaporates, but it stays H2O, which is pretty incredible, okay? Which means it stores up all that heat, the water molecule does, as it goes to evaporation. Then you have this. It's a universal solvent on the face of the earth, meaning it dissolves stuff, but it doesn't react with things. It breaks some of the physical barriers in something, some of the physical unities, but it's not reactive. It's a universal solvent. All life uses water in our systems to convey the minerals from digestion to get to the parts of us. So we're mostly water. We got a lot of water in us. And low density, this is wonderful because water, when it freezes, it turns into a lattice, okay? It becomes a lattice, a highly structured thing, and it's lighter than its liquid form. That's unique, you know? And all the different liquids you look, when it goes solid, it's always heavier than its liquid form, not with water. So what happens in the golf course when water's on the top of that pond or Lake Erie, not our oceans? It means the bottom is not frozen, and whatever life was down there can continue. It allowed life to continue even through the freezing period. That's pretty amazing. It's a unique substance, water, and what it does and how much heat, and we'll see that in just a moment. 5 properties of water: it attracts to other molecules, allows it to get pulled up through plants, and allows for respiration and water to continue. It stores heat. It stores heat in 2 different ways: high specific gravity, high for vaporization. The low density of ice and high polarity means you can latch on something and drag it without being too much more reactive. But aren't all oceans salt water? If you drink salt water, you're in trouble. You will damage your kidneys. It needs to be desalinated. The Soviets used to have, when they were Soviets, they used to have a desalination plant. And it took so much energy to desalinate oceans that it just wasn't worth it, okay? I don't believe they still do it. Maybe technology has found a way to make it happen. But we got lucky. Okay, in the same way we got lucky by having so much water and all the things it does, we got lucky because in the atmosphere, because of water, we have what's called the water cycle. And so water goes and it evaporates off both land and sea. It goes up to higher atmosphere, and what's lifted up is only pure water. It's not salt water. The salt is left. And up there it coalesces. It joins together with other water molecules and becomes precipitation that comes down as rain or as snow. It gets into the groundwater, and it gives the earth a fresh water bath. And that's the stuff that life needs, fresh water, okay? And then it all happens again. If you didn't have that, water being renewed like that, being generated, becoming clean through evaporation, and then condensing at higher altitudes, you would not have life. Okay. Take a few minutes if you want to stand on your feet, get your blood back into your legs, okay? It might be short. We'll just do a few minutes. If you need to go get anything, I'll just let you know about a minute before I start up again. Okay, we're going to keep moving along. There we go. As I said, we're going to keep moving along. How is that? Now, someone just told me it's hard to see. You people that know, especially probably teachers, okay? If you know what a good presentation is, what a good slide looks like, dark background, white letters, really? I never knew that. Send those to me. Send examples of good slides, and I'll remake this whole thing, okay? So, ready to go? We'll catch you up if anyone is not here, but because we still have a lot to go through. This water cycle is necessary for life, but it's not the only cycle, okay? There's also a carbon cycle, okay? There's a carbon cycle, and it recycles carbon in the atmosphere. It looks better. Now, this is fuzzy. If you're trying to read it, these letters are fuzzy, just to let you know. Just get the pictures. Look at the sheep, okay? Imagine what sheep do, okay? So it recycles all that using plants and animals, and it gets into the soil, and if it gets into the water, because the oceans pick up CO2 out of the water, out of the air, right? And it drifts down to the bottom, fills up the bottom, and plankton and dead animal parts and things like that, and that might go into the sedentary rock and be formed and come out on the surface maybe for a rock. But that's CO2 cycle. It's absolutely necessary. We have to have this. Or CO2 and carbon's needed for anything that we have. We take it for granted, but we shouldn't. It's important. There's CO2 in the atmosphere that heats up and heats the surface of our planet also. Remember, just a few miles right out there is a death freeze. Just a few miles, there's an absolute death freeze out there, okay? Some of your worst science fiction movies are based on somehow that death freeze of space touching our planet, okay? B movies, the hero dies or something like that, yeah. So, the nitrogen cycle. Every protein needs nitrogen, and there's a nitrogen cycle to make sure it keeps going, using bacteria, using a lot of the stuff in our soils, okay? Plants and animals. So there's a nitrogen cycle. In fact, there's a ton of cycles going on that we learned in 9th grade physical science. There is, what is this one over here? Lightly a rock cycle. There is, again, the CO2 cycle going down, getting into limestone. When that comes to the surface, water will combine with CO2, touch that limestone, and release the carbon back into the atmosphere. The carbon cycle again, the sulfur cycle, we need sulfur, and that's recycled inside. All this is absolutely necessary for life to have the expression it does on our planet, this incredible variety of life. The Earth also has a rock cycle. Now this is due to plate tectonics. Parts of our crust are moving around supposedly on liquid melted crust called magma. Comes on the surface, we call it lava. The plate tectonics causes continental drift, updrift. Now if you take that uplift with strong erosive power of water and wind are eventually going to wear down everything, okay? A molten core all occur in simultaneous, these three on the same planet to release and recycle elements. That rock cycle is pretty amazing that way. So minerals and basic elements are released from rock for use by animals, plants, and us in water and in soil. All that stuff that might be locked up in rocks because of our planet is released. Now we're talking over hundreds of thousands, millions of years, but it's released. It's not, the surface of the earth will not deplete its minerals. They're being recycled. Kind of reminds you of different cogs inside a real fine machine, right? Things that have to be there, that are working together with one another, interdependent, is almost like cogs of a machine. They're all working, all interdependent all the time, and they're needed for there to be life on this planet. Without any one of those cycles, and there's a lot more, life would be compromised. They are completely necessary. Now let's look at the Earth, our crust. We have a rocky crust, we have an outer mantle, an inner mantle, edges of the plates that come from it, and the core. Again, the core, it believes now it's solid, it's iron, and it has fissile material that are making it very hot. There it is. And what it causes, as things melt here, they go up. And as they get close, they begin to circulate, and you get a convection going. And when you draw that material along the edge, it creates friction and draws parts of the crust across, and when it runs into another crust, it goes down. It runs down in to be melted again and come back up. And like a convection oven, you get convections of molten earth, molten rock. Here's another one. When those two convections are going the opposite way, you get plates that separate, and they're going to see volcanic activity right there. When the plates come this way towards one another, you're going to see one coming up and the other doing what's called subduction, going down. Now look at this. This will eventually be about 1 million years. Africa has that happening. It has two plates, one going this way and this one kind of going off in this direction. And they believe Africa will be split in that way. You can look along that line and see a lot of volcanic activity and a lot of activity in this area. Iceland, that's why you have Reykjavik, okay? Because it's the end of two plates that are going in opposite directions. It will open up. Remember that that cloud we had, that gas cloud and pumice cloud a few years ago that shut down the economy of Europe? Remember that? They think that could have gone on, if you look at the geologic record, it could have gone on for 100 years. Imagine what that would have done. We had one of our brothers, remember brother, our dear brother, he was over somewhere in Venice, and we were like, pray for the end of this volcanic cloud garbage, because he's over there, and who would want to inflict that upon Venice, you know? Pray for that guy. Land, yeah, yes. Yeah, Lanigan, Jordan. Okay. 10 million years in the future, this could be our Earth. Yeah. Yeah. So we could see this in North America. We could see some things gone. And what's it because? It's because we got moving planets. We got moving continents, okay? And they're rising up and falling. Here is what it looks like right now. Here's the Pacific Rim, a lot of ring of fire, they call it. There's our western coast. Now, this is absolutely necessary. Plate tectonics. This is very interesting because most people haven't thought this one through. Plate tectonics allows recycle of elements by subduction and convection, especially carbon, which is needed for temperature control of the surface. We have to have carbon. It soaks up energy. Within a thin crust, plate tectonics allows heating of a planet with volcanic vents. So let me go show you again. Everywhere where that is, you've got heating of water or air on a superheated level, and it keeps the planet from the death freeze that's only a few miles up. It stabilizes the balmy climate of our planet. We need that. Again, there's a death freeze that kills life because it stops all chemical processes. That's why in my family growing up, we always put batteries in the freezer. Did any of you guys do that? We always put batteries in the freezer because it stops the chemical processes. It makes them last longer until you use them. And this is speculative. It may have kept our planet from becoming a water world because of the eroding power of water. Water tears down mountains. And by having land kept getting pushed up by plate tectonics, it doesn't allow the erosive power of water. If you take the depth of the Pacific and some deep parts, and you take the continents above the water, and you kind of cut them off and put them and pack in the depth of the Pacific, you can get a water world with our planet. There's greater depth to our oceans than there is land above the water. That has the makings of a water world if you don't have plate tectonics. And this is an advanced thought, okay? The same forces, plate tectonics, volcanism, continental drift, recycle of elements, heating of the ocean, of the air, oceans of water on our surface, all that stuff that we benefit so in an incredible way, that caused, when that 9-point earthquake went off in 2004, remember, December 24th, I remember that one. We took up a collection at the place where I was. It went off there, estimated 250, probably 300,000 people. Those same forces were involved in saving the lives of 6.2 billion people on the very same day, from space freeze, from being a water world, from the destructive solar winds. The very same forces that ended up in people dying saved 6.2 billion people that day, because we live in a hostile universe. The forces are against what we've got here. We got very lucky, incredibly lucky. Note this observation from renowned scientist L. Sessions, and this is something just to think about. This is weird, okay? This is from a science blog, and it's 10 Surprises About Our Universe, Solar System. You can look that article up, 10 Surprises About Our Solar System, number 6. 6, almost everything on Earth is a rare element. The elemental composition of planet Earth is mostly iron, oxygen, silicon, magnesium, sulfur, nickel, calcium, sodium, and aluminum. While such elements have been detected in locations throughout the universe, they are merely trace elements, vastly overshadowed by the much greater abundances of hydrogen and helium. Thus, Earth, for the most part, is composed of rare elements. We got really incredibly lucky in being in a planet that has our chemical composition. Okay? This guy admits it. He doesn't take it any further, and I don't want him to. He's a pure scientist. But we got lucky on this planet by having a chemical composition like we do. There's another thing going on, and this is one diagram of it. Do you remember that spinning iron core that's in the center of our planet? Do you know what you get when you spin iron? Back in 9th grade, we would spin iron. You get magnetic fields, yeah, a type of gravity. An attraction. Here's an artist's rendition. The sun is putting out solar flares and solar garbage. It is a nuclear explosion. Why doesn't that hit the Earth and fry us? We're close enough, because we have, as one science magazine said, a Star Trek-like force field around our planet. We got really lucky by being on a planet with a spinning iron core. And so the solar energetic particles, the solar particle events, coronal mass ejections, solar flares, whatever, that stuff's spitting out garbage, okay? You can't grow fine plant-like structures or DNA or wonderful cells. Here's a eukaryotic cell like ours. The fine structures in something like this, it can't grow when you have solar garbage frying it, causing problems in the chemistry. And so, alas, Mars, such a pity. Mars does not have a solar force field. And everyone's talking about colonize Mars, colonize Mars. The moon benefits from our solar force field a bit, our moon, okay? Mars doesn't have a magnetic force field. It's going to be very interesting when we send people to Mars. I wouldn't be in the first group, okay? Because I've only seen this mentioned once. Right before the movie Martian came out, one journal came out and said, Mars is losing like 500 grams of atmosphere a second because it's being punched by the full force of the solar winds. The atmosphere is being torn apart. Well, let's plant plants. The oxygen will be torn apart. It's about a McDonald's Big Mac per second. That's about 400 grams a second. Okay, so not much, but it's going to cause problems when you have people living in tents, right? Thinking they can just plant potatoes and colonize Mars. That article said, way before the movie Martian, said, don't look to Mars unless you go underground, maybe. But Mars probably is not able to be colonized because it doesn't have that protection. This is a rendition of what Earth is like. That's Mars. It has little pockets of it, but nothing as strong as Earth. Here's another rendition of the magnetic field. Van Allen belts, they're called, the fancy name. But the magnetic fields, it's a magnetic force field. And in science journals, a Star Trek-like magnetic field. When Scotty's told, give me full strength of shields, we got it, okay? We've got it, it's amazing. And you see its work when you see those northern lights. That's the friction of the masses, electronic masses going past the Earth, touching our magnetic field. That's the northern lights. If you still see northern lights, that's a good thing. That's why I'm against destroying the ozone because it stops some of the solar particles and things like that. Yeah, it's pretty rare. Venus doesn't have it. Mars doesn't have it. The moon benefits from us. Io, I think it's near Jupiter, may have it. Mercury has a little bit, but it's too close to the sun. You're going to be fried daily at Mercury. No magnetic field means no protection from the solar winds equals no life on that planet. If you don't have a magnetic field, if you don't have a plate tectonics, if you don't have a hot spinning core, you're not going to have this. And so there'll be no life on that planet. Not only do you need liquid water, not only do you need the proper thing to protect you from the solar garbage, you need that magnetic field, a stabilizing moon, big chili pepper on that magnetic field. And so, because of it, isn't that dog cute? Because of what we've got here, we therefore have calm seasonal change, and that's easier on life and forming DNA. We have a moist environment that allows life processes because water does so much. We have things so that plants like that and animals like the cute doggy, life can grow and abound. And the 6 killers of life of the universe are overcome here on Earth. And they are the 6 threats found in the universe: cosmic rays, all the garbage spinning off stars. O2 and nitrogen collide, react, and stop, and the magnetic field and ion field divert them. We've got that in our atmosphere. Danger 2, X-rays and potentially gamma, but not from our sun. X-rays, though, same, it's very effective. They get caught, they collide with things up in the atmosphere, it's very effective. Danger 3, ultraviolet radiation. The ozone layer stops it. That's why I don't like fluorocarbons, because we need that ozone layer, lest that kind of stuff increases in strength. That's still why we need a little bit of suntan lotion. Number 4, periodic solar flares, coronal mass events, winds, the magnetic force field comes to play. Number 5, freezing temps of outer space. The atmosphere holds enough water. Our atmosphere, that thin line of atmosphere, holds a lot of heat. Water can store and release heat. The crust is thin, so we have volcanism. So the freezing death freeze of outer space doesn't touch us. And number 6, how about the vacuum of space? Earth's gravity keeps its atmosphere. If it was any larger, it would have kept more hydrogen, but it lets some hydrogen off. And that means the Earth crust, we would have had more acidic if there was more hydrogen. If it was any smaller, we'd be losing our atmosphere all the time. We got incredibly lucky by having these things around us. And these are all, those 6 are extinction level events, okay? If one of them hits us, you're gonna start seeing the human race dying off. Those things are shooting at us all the time, yet they're missing us all the time. Yet here we are. Also on Earth, and I'm getting close to the end, we've got this incredible difference from real hot places to real cold places, and from real wet places to real dry places. And those interactions and life have caused a whole bunch of stuff to happen so that we have incredible differences of forests and grasslands, and I can't even describe all the words that would go into all the things across the face of the earth. An amazing variety with life on all forms being formed. And with plants, they do something amazing. They take in sunlight, carbon dioxide, which is plant food, okay? It's not just a greenhouse gas, it's a plant food. And they take in water and minerals, and with sunlight, this water and minerals, they produce oxygen, which we breathe, that's good stuff, and they give us plant sugars in the form of fruits, and we love our fruit, okay? So because of the variety, our planet is like a cornucopia for humans. It's amazing what we can eat. It's just fascinating. That is a gorgeous picture of just a small fraction of the variety that we have as far as edible things on this planet. Also, you've got all these animals, these wonderful animals out there, little ones from bugs to the giant things, these majestic animals. And frankly, if you're really hungry and you have a Weber grill, it's all food, okay? I hate to say it, don't tell that to kids, but if you're hungry enough, cats are the other white meat, you know? So, it's all food, okay? Salmon, that's great. You got to be really hungry to eat something like that, right? Okay? Look at the cute little guinea pig. Down in Peru, they eat guinea pigs. And that's because you have a Weber grill, okay? All this is independent and necessary, like this. 5 things coming together. And I'm thinking the book, where's my book? There's probably 20 things coming together. I didn't even know them as far as the chemistry, the paper cut, who made the paper, the glue involved, the fabric. I think there's like maybe 2, maybe 3 types of paper in here. There's fabric in the spine. I think this is a leather, and that thing was grown. But all these 5 different things come together, and it just shouts engineering. 5 different things coming together, and this says this was engineered. An intelligence is behind it, okay? And so, let's do the math. A terrestrial planet made of rare materials, soil and water. You added that, a universe where the laws of physics, chemistry are ordered. Lots of liquid water, we got lucky, we got really lucky with that. The right atmosphere, we got lucky. It's thin for white light to get through, but it's protective, and it has oxygen. The right size stabilizing moon, it stabilizes tilt, tide, seasons, and speed. Having plate tectonics and volcanism still working. The right size planet for a just right strength of gravity. So it's not too big, not too small. It's the Goldilocks, they called it, the Goldilocks theory. Found in the right location in our solar system and in the galactic habitable zone, in both of them. Right age star that gives us just the right kind of radiation, not gamma, not the useless stuff, but white light, which touches the earth and makes things happen. The planet having an iron core with fissile material in it that continues to heat so we don't die from the death freeze. With planetary rotation, which forms a protective magnetic field. Protective big brother planets to catch space garbage that's out there, and lots of plant, microbial, and animal life to help to be food for us. All that is going on. We got incredibly, incredibly lucky. 25 times we've gone through discoveries of science, and we got lucky over and over and over again. But maybe it's not luck. That's why, this understanding is why we love science. We want more study in science. We want to know more of what's there in science, because that's what science does. It says what's there. It doesn't say why there, and it doesn't list them in order. If I told you one of these things, we have a moon, you'd say, big deal, let's write a song about it, Blue Moon or something. But when you list them and you see and you hear, we got lucky, we got lucky, we got lucky, over and over and over. No one gets that lucky. So, ever since the creation of the world, his invisible nature, namely his eternal power and deity, has been clearly perceived in the things that have been made. The end. Because you've been so good, you haven't thrown anything, I have something for you, okay? You can come up, that's why I said give me a little after 6. This is perfect timing. You can come up, you can look at these things. This and this are the same thing of engineering. The book, the cell with this incredible stuff. In a flash of a second, the cells of the, let's say the hormonal system, okay? The different glands are sensing what's going on, what you need, and they're giving the proper response, making it and packaging it and sending it out. Just like, bam, just like that. That's incredible. That would be interesting. I've never done it. This is looking out at the cosmos. It would be very interesting to look back into the human person. The smallest, this probably has 200 parts to it. Anyone know? Let's say 200, okay? The smallest chromosome, what is it, chromosome number 2? It's got 48,000 parts. 48,000 parts. We demand that this is made by an engineer, an intelligence, not tornado upon hurricane upon lava. We demand people to say that this is made by an intelligence. Well, if the lesser is made, why not the greater? The greater complexity of things. So that's why we love science. Now, because you have been so good, I do have some prizes for you. Okay? Woohoo! And because it is a retreat, The dispensation from eating such things lasts until 11:59 tonight, okay? And so, let us find, do we have anyone here that is 15? Scream if there's anyone at your table that's 15, 16, 17, 18. 17? You get a prize. Okay. Where are they? If you could open this up, have a creamy egg. Okay? Cadbury eggs. 18, 19, 20. 20, come over here and grab a Cadbury egg. 21, 22, 23. I'll get to the, I wasn't going to ask, excuse me, ma'am, what's your age? Oh, no, you don't do that. 24, 25, 26, 27, 28. The college students are out at home pounding the books, aren't they? 29, 30, 31, 32, 33, 34. I need 2 more people to want an egg. Come on. This is taking too long. 35. Oh, there you go. Great. Someone give him an egg. If you'd be could you be my runner? Yeah. Sir, okay. Could you give him an egg? Are they done? There should be 4 in there. Oh, yeah, you don't get the whole box. Oh, my golly. Okay, so that's creamy eggs. There's another one. Let us look. If at your table, if you look at your table and you have a piece of tape on the edge right where you're sitting. Anyone have a piece of tape? A red piece? You have a red piece. Can you go take him an egg? Anyone else have a red piece? Oh, look at this. Okay, you win a prize. Could you take it to that lady over there?
I almost took it off.
Oh, I'm glad you did. If you would give that to her also. Okay, that's wonderful. Anyone else? Because with a couple seats open, they may not be sitting in it. You have another? Would you run an egg back to her? Okay. Next. Okay, next, let's see. At the top of your chair, right at the top, where you grab it, is there a yellow piece of tape? Is there a yellow piece of tape at the top? Claim this chair. Can you take, my dear runner friend, can you take a Pringles can, because you win a Pringles can, to that gentleman right there in the black and white check shirt. Anyone else? There's another. Anyone else? Okay, you get a Pringles can. Isn't that awesome? Does anyone else have a yellow piece of tape right at the top? Back there? Anyone? It's around here somewhere. Keep looking. Okay. Next, does anybody have a green piece of tape right in the middle of their seat, right in the back of it? You, sir. Oh, my golly. Can you believe that? You get some trail mix. I had a whole team in here. Putting tape up here, and you got hit with 2. Wow. Next. There's only one of those. Do you have a dark piece of blue tape on the table before you? There's one. I think there should be one more. Over there. 2. Okay, you folks win. Aren't these awesome? How can Fritos go wrong? Okay, you win Fritos. They don't. Good job. Okay, progressing on. I'm looking at the left leg of your chair. The left leg of your chair, by your ankle, is there a yellow piece of tape? You got a yellow piece of tape? Yes. Okay, and you get Benedict. This is Benedict, World Youth Day and other Cologne talks. Benedict is awesome. Next. Do you have, at the right front corner of your seat, do you have a piece of black tape? At the right front corner of your seat, is there a piece of black tape? You may need to look. This gentleman has it again. Holy cow. You get Steve Ray's St. John's Gospel to have while you're eating the nuts. Holy cow, look at that. Today's your lucky day. How about On the handle of your chair, do you have a piece of white, thick tape? On the handle of your chair? Okay. So what do you win? Oh, you get to get this one. This is on the rapture. Okay? Learn about the rapture, become an expert in it. We don't buy it as Catholics, but this is Sophia Press. That's just fun. Okay. Next, moving on. On the chair seat, if you would stand up, is there a red piece of tape on your chair seat? Anybody? Hey! Is that red or is that orange? You win a Marvel comic thing. Okay? Next. Is there an orange piece on the right edge of your chair? Oh, this gentleman again. Holy cow. You're getting Privilege Planet movie with popcorn. This is a great movie. I got some of my info from there. Okay. Next. Is on your left side of the chair, is there some clean tape on the left side of the chair? What's your name? What's your name, sir? My team was in here, and we just randomly put it in here. This is amazing, because you just got, what did you win? Oh, who else? Anyone else have tape on the left side? There's supposed to be 2 of those, says my list. Anyone else? Look for it. It's probably one of the chairs on the left side. Okay, next. Is there a gray tape X on the floor underneath your feet? You got it? Good. Someone else. Someone else has a gray X? What's going on here? This is really bizarre. You get Arizona tea to have with your movie and your popcorn. Okay. Go figure. How about closest birthdays? Whose birthday is this next week? Oh, and you? Does she have it? Okay. I'm like, wow. How about who has a birthday this next week? The week after? Hey, that counts. Ho, ho. Eggs. Okay. The week after that. There you go. Anyone else? You? Okay, those are Reese's Pieces eggs. The Savior of the universe is rising. Watch the eggs. Okay. Anyone else? The week after that. In a month. Okay, if you would come up and get this, sir, I'm going to have to fix this. So, I heard some people saying, sir, look at you. You should go buy a lottery ticket. Okay? My name is spelled B-L-A-U. Okay? Yeah. So I heard someone say, because especially some people who didn't win a thing, all those prizes went out. If you really want one, this needs a home, that Pringles can. And we have 2 little eggs in here. And we have some of the Andes, okay? But someone did say that's not fair for one person to win like that. What's going on there? Why? Huh? Because no one gets that lucky, right? Winning how many times? 6 times he's won. When some people didn't win one, no one gets that lucky. Do you feel it? What it's like? No one gets that lucky. You just experienced what's going on with us and the rest of the galaxy and the universe. No one gets that lucky. It's rigged. This is all rigged, okay? I was hoping someone sat there, okay? Like, holy cow. I'm looking saying, okay, I hope someone sits there, and I don't know where the other ones are. There's 3 prizes still to go, okay? So one of these empty chairs may still have a claim. But, oh, come on. Pringles? Okay. Come up. Afterwards, you can get Pringles. But that's what it is. It's rigged. When you see this kind of a system, where'd my little clicky thing go? Well, you saw it. When you see it, it's rigged, okay? No one wins that many times, and we've won that. The latest thing is there's about 200 parameters necessary to have life like we know it. So if there is life anywhere else, it's going to be as rich as we are, It's got to have these things, because you wouldn't have our life if you're missing any of these things, and a bunch more. So that's it. That's why Catholics love science. Great. Thank you. I didn't put these things out because I was thinking if you put these out, they're going to be reading it and, golfing and, oh, come on, I knew that because you read it. These are 3 articles, one from Live Science. These aren't religious sites, okay? They're science sites. One from Science, How Stuff Works, okay? And one from, where are you from? I think it's University of Minnesota, the last one. And these are 13 incredible lucky facts. And so I recommend come and get one per household, one per family, and enjoy it. It reviews some of this stuff, and it brings up something new. You gotta love our Earth, our planet. It's pretty awesome. Thank you.